Okay, beta, the recording of the session is on now. So yesterday we were discussing about the concept of PZX triangle. So we had discussed about the equinoctial system of reference. Then we went on to the horizon system of reference. And then we saw the PZX triangle being formed on the celestial sphere. So today we are going to proceed ahead and we are going to see how this PZX triangle concept is used for solving questions in celestial navigation. We will see how the PZX triangle can be converted and shown on the rational horizon diagram. And from this rational horizon diagram, we will be able to solve celestial navigation based questions. So that is what we are going to do today. बेटा आज जो हमारे जो ब्रेक टाइमिंग्स हैं आई विल स्लाइटली मॉडिफाई दोज ब्रेक टाइमिंग्स आई have a little meeting scheduled up, so we will have a break between 12 to 12:30. Okay, then after 12:30 we can continue till the time the topic finishes off. Okay
sir.
Right. So beta, before I start off with the presentation, any doubts in your mind related to what we already discussed? The equinoctial system, the horizon system. Let me show you the presentation and let me revise the steps one by one. Okay, so this is what we did in the previous session, beta. We discussed about the concept of celestial sphere. We saw the equinoctial, the celestial poles, and the celestial meridian. Then we went on to the horizon system, and in the horizon system we saw the zenith and the nadir. Then exactly midway between them, the rational horizon. Then the directions being represented on the rational horizon, that is N, E, S, W points. Then we discussed the concept of a vertical circle. The semi-great circles contained between the zenith and the nadir of the observer. And on this vertical circle, we had a celestial body. We found out what was the true altitude of the celestial body, represented by HX, the maroon color arc here. So we found out the true altitude and we found out the zenith distance or the true zenith distance TZD of the celestial body, which is 90 minus true altitude. So this is what we discussed in the last session. So any doubts in your mind related to these, beta?
No, sir.
All clear? Very good. Then we covered up the concept of the PZX triangle. I believe it was covered up, na beta? I told you about the three sides of the PZX triangle.
Yes, sir.
Right, very good. So we saw the three sides. The side ZX is the true zenith distance or 90 minus true altitude. The side PX is the polar distance or 90 minus declination. The third side, which is PZ, the yellow highlighted side, was the colat, which is 90 minus latitude. So this was the last what we did. So anything bothering you up to the PZX triangle and its three sides?
No, sir.
Okay. All right, beta. So now we proceed ahead to an important concept to show this PZX triangle in the rational horizon diagram. So what I'm going to do is I'm going to pick up this particular diagram from here as it is. You see this PZX triangle highlighted here. So we will pick up this diagram from here, take it on the next slide. And then from this diagram only, we will try to make the rational horizon diagram. So let's proceed ahead. Now, having understood the concept of PZX triangle, we have first understood the equinoctial system, then the horizon system, and we are now able to see the PZX triangle on the celestial sphere. So let's now try to convert this PZX triangle to the rational horizon plane. Now this diagram which you see on the screen right now is exactly the same diagram picked up from the last slide. All the things which are mentioned here we have already discussed. You see this PZX triangle here. It is the same PZX triangle. PZ side is the colat 90 minus latitude. ZX side is the true zenith distance, which is 90 minus true altitude. The side HX represent the altitude of the body. And the third side PX is the polar distance, which is equal to 90 minus declination. Now, it will be very difficult for us to make this kind of diagram. This is actually a 3D diagram represented on a plane surface. And for solving the questions which are based on the PZX triangle, if we need to make a diagram like this, it will be very, very difficult, hard, as well as time taking. Especially in the examination conditions, if you have to make this kind of diagram in every question, it will take a lot of effort as well as time. So to show all these things in a very simplified version, we can simplify this particular diagram by simply looking at it from a different angle or from a different perspective. Now, how do we look at it? Let us try to understand it now. First of all, you see, we are only interested in that part of the celestial sphere which is above the rational horizon. That means this particular part, which contains the PZX triangle also. This is the part which we are interested in. We are not interested in the bottom part of the celestial sphere that is below the rational horizon, because that in any case will not be visible to the observer. So we are not interested in this particular part. Now, how to have a perspective or angle so that this bottom part can be eliminated altogether and we are able to concentrate our attention to the top part. So for this, we visualize as if we are looking at the celestial sphere from top of the zenith. Right now, we are looking at the celestial sphere somewhere from this west point, somewhere from this angle we are looking at it. But assume for the moment that you are able to go up to the zenith. Let's say you have a rocket accessible to you. You sit in the rocket, it takes off and it goes vertically upwards. Now, if that rocket goes vertically upwards, eventually at one point of time, it is going to reach the zenith of the observer. Now, we don't stop at zenith. We take the rocket still further upwards. Now, let's assume that the rocket has reached up to here. So once we have reached up to here, now we look down below towards the celestial sphere. So we are outside the celestial sphere now, and we are on top of the zenith. And you can say we are having a bird's eye view on the celestial sphere from top of the zenith. Like you see, many of the shots are taken by drones nowadays. So the drone flies high up in the sky and it takes a bottom picture, a aerial view. So that is what we are looking at it. So right now our eye, or we are situated at where the laser pointer is, and we are looking down at the celestial sphere. Now, how does the celestial sphere appear? We will try to put it in a diagram on the right hand side of the screen. So in the blank portion now you will see how does the celestial sphere look from top of the zenith. Now, first of all, the celestial sphere looking from top is going to look like a circle again. So it will appear like a circle as you see on the right hand side of the screen. Now, when you are looking from top, you see this was the north point. The circle which we have made on the right hand side is basically the rational horizon of the observer. When you are looking from the top, the circumference of the celestial sphere will be the rational horizon of the observer. Anything which is below the rational horizon will not be visible to us. It will go on the far side of the celestial sphere. We will only be able to see what is on top of the rational horizon. So when we look at the celestial sphere, the circumference of the celestial sphere which we are going to look at is the rational horizon. So the circle which we have drawn on the right side of the screen represents the rational horizon of the observer. And that is why the name given to it as rational horizon diagram, because it is made on the plane of the rational horizon of the observer. Now you see we have this north point on the rational horizon. Now, as per our sign convention, we show this north point on top of our rational horizon diagram. It matches up with our charts also. We have the north direction represented upwards. So here also in the rational horizon diagram, we represent the north direction up. Now, exactly opposite to this north direction on the other side, you will have the south point. And if you go 90 degrees towards the right side of north, you will have the east point. And if you go 90 degree towards left side of the north point, you will have the west point. So let us mark off these points in our rational horizon diagram. We have the north point here. If you go to the right side by 90 degrees, you will reach to the east point. So you see represented by E in our diagram. And if you go opposite to the north point, exactly opposite to where the north point is, exactly opposite to it, you will have the south point represented by S in our rational horizon diagram. And if you go 90 degrees to the left of north, you will have the west point represented by W here. So all these 4 points, N, E, S, W, represented on the plane of the rational horizon. Now you see, going from north up to the north celestial pole, from the north celestial pole going up to the zenith, up to Q point and up to S point. This is going to look like a straight line joining the N and S points. So if you have a look at this from top, it is going to look as a straight line joining the N and S points. So let's see it here. It is going to appear as a straight line joining the N and S points. Beta, are you able to understand up to here? Any doubts in the mind?
No, sir.
No, sir.
Okay, very good. Similarly, if you draw a vertical circle, which will pass from the zenith and pass from the west point, this vertical circle passing from the zenith and the west point, and also a vertical circle passing from the zenith and the east point. So going from east up to the zenith and coming back to the west point will also look like a straight line when you look at it from top. So you see this is the W to E vertical circle line which we visualized in the celestial sphere, and exactly in the center you will have this Z point. When you look from top, the circumference will be the rational horizon, and this Z point, that is the zenith of the observer, will be exactly in the center. So let us show this Z point exactly in the center here. You have the Z point here at the center. Now from Z, if you move towards the south point, from Z moving toward the south point, once you cover an arc equal to the latitude, you reach up to point Q. So let's mark off this Q point in our rational horizon diagram. So from the zenith, when you move towards the S point and you move a distance equal to the latitude, you reach up to the Q point here. So from the zenith towards the south point, we moved an arc or distance equal to the latitude. We reached at Q point. So this Q point represents the Q point here in this diagram. Now, if you look carefully, from the Q point, if you join up the W point, W to Q, and moving further Q to E. This particular arc, E point to Q point to W point, represents the equinoctial. So we can also show the equinoctial in our rational horizon diagram now. You have the W point here, you have the Q point here, and you have the E point here. So joining W to Q to E will give us the equinoctial. So let us do that. So you see W joined with Q joined with E gives us the equinoctial. So this WQE represents the equinoctial in our rational horizon diagram. This WQE you can see here in the celestial sphere diagram. This is point W going up to point Q, going up to point E. Only this part of the rational horizon will be visible to you. If you go beyond W on this side, or you go beyond E on this side, this is going to fall in the far side of the celestial sphere, which will not be visible to us. So this will not be visible to us. So that's why you only see half of the equinoctial, which is visible to you as WQE in our rational horizon diagram. Now let's proceed ahead. Let's come back to the Z point. From the Z point, if you go towards N point, towards the north point is here. So from Z, if you move towards the north point, equal to a distance which is your colat or 90 minus latitude, you will reach at the north celestial pole. So let us show this in our diagram now. We start off from the Z point, we move towards the north point, and we move a distance equal to 90 minus latitude or our colat. The point where we arrive is the north celestial pole. It is represented by P. So let's mark this as P here. You can see the north celestial pole shown in our rational horizon diagram. Let's mark off the arc P to Z also. So this is marked in yellow, exactly same as was marked in the celestial sphere diagram. So you see P to Z was marked as yellow, and it has been marked as yellow in the rational horizon diagram as well. This is equal to 90 minus latitude or equal to the colat. So beta, everything is clear up to here. Any doubts?
No, sir.
Okay, very good. So beta, just give me some time for break now, so you can take your break, and we will meet back at 12:30. So you can have your cup of tea and coffee. So we'll meet back at 12:30 and we will continue from here.
Okay, sir.
Right, beta. Right.